For Scientific American Science Quickly, I'm Kendra Pierre-Louis in for Rachel Feltman. Cancer. It's a diagnosis that most of us have learned to fear. On the one hand, decades of medical advancements have increased treatment and survival rates. A number of people who in the past might have died from cancer now go on to live long, full lives without recurrence. But not everyone is so lucky. For certain kinds of cancers, including cancer of the pancreas, effective treatments largely remain elusive. So increasingly, researchers are looking to perhaps an unexpected tool for help: vaccines. It turns out that before mRNA vaccines became a key tool to protect people against COVID-19, researchers were initially eyeing them as a way to target cancer. And that work continues. To learn more about how mRNA vaccines can help battle cancer, we're talking to reporter Rowan Moore Gerety. He covered this topic for the December edition of Scientific American. What inspired you to write this story?
When this first came on my radar about a year ago, partly I was just surprised to be reading kind of frank mentions of cancer vaccines because, growing up, we think of vaccines as one of these miraculous interventions in public health that can basically eradicate a disease, right? So it's important to note that in the cancer context, these are therapeutic vaccines. So it's not about providing immunity on the level of the population, but all the same, it's the same kind of mechanism. And so I was just really interested to understand, wow, this is an approach that is seeming like it may be viable for cancer. That seemed like kind of a paradigm shift to me because my father's a cancer survivor. I have, as we all have, grew up hearing of people becoming gravely ill and dying with different forms of cancer. And it often just seems like a roll of the dice. To some extent, it still is. But just the notion that there are interventions that might have what I guess in my sort of layperson's brain, like a vaccine level of effectiveness, seemed kind of astounding. And so I was really interested to learn more.
Before we get into sort of what makes these vaccines so unique, I think kind of on the specter of cancer and the living with cancer. In the story, you talk to Barbara Brigham, a woman who has been in remission from pancreatic cancer for 4 years. And that's a disease where most people don't make it 5 years. What was that kind of like talking to someone who, absent this treatment, should be dead?
It was really inspiring. I mean, she is a very wry personality. This maybe came across a little bit in the piece. She has what I associate with a kind of grandmotherly wisdom and very sort of upbeat spirit. But I think if you have known anybody who gets a pancreatic cancer diagnosis, often it's something that is sort of diagnosed as a terminal illness. There is nothing to do but sort of treat it and see, can we get a few more months or a few weeks even? And as I note in the story, she has been able to do quite a lot. She welcomed a new grandchild. She got to see all these volleyball games of her other grandchildren. She saw one grandchild get married and another start graduate work. And she lives on Shelter Island, which is near the tip of Long Island. And she sort of has had a very active and full social life, partly not necessarily as a cancer survivor support group, but the way she explained she has these weekly get-togethers where they play mahjong and eat dessert together, which sounds just lovely. But she's in her late 70s. The people around her, I think, are in their late 70s or 80s or even in some cases 90s. And so there's a little bit of a quality of support group to, I think, any socializing you do in that phase of life. Everybody has lost spouses, siblings, parents are long gone. And so I think it has been really meaningful for her to be able to convene a group of people and talk about surviving and talk about enjoying life on a day-to-day level. One thing I love that she said to me was her mother said you should try to have a little bit of adventure every single day. And she's adopted that as kind of a maxim over these last 4 years. And I think it's really served her well.
I also like that, the thing that is ailing her the most right now, at least that you put in the piece, is her touch of arthritis. Meanwhile, she had pancreatic cancer. And it's funny that the thing that she's the arthritis,
And she also survived breast cancer, actually, I should note,
wow.
in the interim. This did not make it into the story. While she's been in remission from pancreatic cancer, she has fought off about a breast cancer, as I understand it. That actually was communicated to us since I spoke to her. Yeah, she has gone through a lot and obviously has maintained a kind of positive point of view.
Can we talk a little bit about how mRNAs work against some cancers and how that sets them apart from existing treatments or existing understanding of like how cancer works?
So one of the things that makes cancer unique among diseases, or relatively unusual, is that it's not like a virus where you have this pathogen that's introduced into the body and the body goes, oh my God, you look really, really different. I better go after you and attack you with all my might. Cancer, because it arises from these genetic mutations in our own cells, a tumor's genetics end up looking quite similar to the rest of your body's genetics. And so it creates a kind of a quandary for the immune system of figuring out where is that line. Researchers talk about self versus not self. And one of the kind of riddles of cancer treatment for a very long time has been how the body manages to make that distinction and how we can kind of put our thumb on the scales with medical interventions to accelerate immune responses to cancer. The earliest interventions into cancer were major surgery, right? Let's just cut out much of the organ or all of the organ that's being affected, and to some extent that still happens. And then you have chemotherapy and radiation, which are targeting still pretty broad parts of the body or systems within the body. And so naturally through all those things, there's a lot of collateral consequences. If you've ever talked to somebody who's going through chemotherapy, they're really tired. It's like an extremely exhausting, taxing process. And part of that's because like you are absorbing these chemicals into your body. They're pretty toxic. So these are not things that you would do to yourself absent having a life-threatening disease. What is different about mRNA vaccines, and in this, they're kind of part of this newer generation of treatments that are called immunotherapy, is that they are trying to leverage that immune response. And there's one more distinction to draw here, which is that about 30 years ago, researchers started to have success with something called checkpoint inhibitors. So in our body, we are always fighting off pathogens of one kind or another. And the body's always deciding, like, do I need to pay attention to you? Or, oh, is this thing over here more serious? And so part of what controls that immune response is a group of proteins called checkpoint proteins. And cancers can actually kind of trick the body using those checkpoint proteins to say, hey, don't worry about me. It's all good over here. We can turn off your T cells, those killer cells that would normally come after a tumor, and instead just let the tumor grow. So checkpoint inhibitors are a class of drugs that has been around for 20, 25 years that act on that capacity that tumors have to sort of shut off your T cells using checkpoint proteins. And so that's sort of the basic hallmark of immunotherapy, is they're trying to intervene in the immune response. But in order to intervene, there has to be an immune response. And what's new about mRNA vaccines is that mRNA is really just a set of genetic instructions. And so rather than your body needing to know, hey, this is what your cancer looks like, the mRNA vaccine can actually tell your body, hey, this is what your cancer looks like. And in that way, it can help your body form what people call a de novo, or a brand new immune response, rather than just amplifying the existing immune response, which is what earlier forms of immunotherapy have done.
And my understanding is researchers who are using the mRNA, it's not like a standalone thing. You don't just get a one and done shot and you're on your merry way. It's like used in conjunction with other immuno treatments.
That's right. So because cancer is so serious, and I think because of, the Hippocratic injunction, do no harm, you can't just say, well, to find out if this works, we're going to withhold the cancer treatments that we know work a little bit and just give you the shot and kind of see what happens. So the people who participate in early studies, or really any study of mRNA vaccines, and this is now quite a huge area, there are 50 some odd trials going on right now. All of those people are getting kind of state-of-the-art treatment, whether it's chemotherapy and immunotherapy, surgery, or radiation and immunotherapy, right? Whatever the sort of cocktail of interventions that researchers determine is like the best treatment for that form of cancer. And then they're also getting these shots over the course of a few months or a year.
One of the things that surprised me in your piece was that, for most of the world, and I think for most people in the U.S., mRNAs are sort of synonymous with the COVID vaccine. That's the thing that we think of. But we're kind of thinking of it a little bit backwards, which is they were tinkering with this treatment in order to treat cancer. And then the COVID pandemic broke out and they were like, hey, we actually think we can use this as an inoculant against this, very deadly virus.
Yeah, this is a fascinating story and one that I was not familiar with through the pandemic, even though, I have at this point many mRNA shots in my arm. So two of the people who have been really critical in this history are the founders of BioNTech, which is one of the companies that came up with the first sort of viable COVID-19 vaccine right at the end of 2020. So this is a Turkish couple in Germany named Ugur Sahin and Özlem Türeci. And they first became interested in mRNA as cancer researchers 30 years ago because they were looking at precisely this question of how can we find a way to boost the immune response and how can we personalize the response. So, a little while ago, I was talking about how cancer really looks like any other part of your body. Your cancer is going to look more like you, perhaps, than it'll look like my cancer. And my cancer is going to look more like me than our cancers will look like one another in some sense, right? There are mutations that arise from our own genes. And so even, a generation ago, the founders of BioNTech were really interested in figuring out, how can we personalize treatment? And they decided to kind of bet on mRNA as a platform. And the reasons that they took this approach is that mRNA is a set of genetic instructions. And one of its real strengths is that it's very flexible. When you change between one patient and another or one disease and another, you don't need to start from scratch. You can just go in and basically splice out a portion of those genetic instructions and say, okay, now go look for this genetic mutation, and everything else in the molecule can remain the same. And so when I say everything else, what that means is the cap and tail that essentially say to the mRNA, go to this part of the body, try to be stable, right? The body's kind of a messy place. Don't get corrupted or kind of thrown off your axis by whatever's going on inside us, and deliver your jolt, right? So they spent decades really tinkering with that cap and tail, the rest of the mRNA molecule, in order to say, hey, how can we make this really stable? How can we make it persistent? And also, how can we make it powerful enough that it will engender a really strong immune response? When you're going after a virus, your body produces antibodies. Those antibodies can then go throughout your body and sort of do their thing and go after it. When you're going after cancer, it's actually the immune cells themselves that need to attack the cancer cells. And so what that means is, in terms of the demands of your body's immune response, it's much, much larger. I think they told me you have somewhere on the order of tens of thousands of cells that would need to be active and creating an adequate immune response to fight off a virus, because those antibodies are always circulating looking for the first signs of an invasion. But where a cancer response, you might need billions of T cells to be engaged. And so in order to sort of customize the mRNA, they had to figure out how can we make this molecule work so that it can generate a big enough immune response. So they spend decades doing this, kind of tinkering with the mRNA, finding a form they like. Along comes the pandemic and they say, I think mRNA could really help here because it's so flexible. Each time the COVID-19 virus changes, we can just tinker with that middle section and then spit out a new vaccine in a few weeks. And lo and behold, that's exactly what happened. And that's what allowed us all to get boosters throughout the pandemic that were tailored to the genetic versions of the pathogen that was sort of most in evidence around the world, so that when Omicron became a thing, the vaccine's tailored to Omicron, and you can suppress whatever wave is happening that looks like Omicron. So then after the pandemic, again, they realized now we have this incredible proof of concept. All of that decades of work we did sort of pursuing mRNA vaccines as a good platform for cancer treatment. Now we have shown people that it's safe. We have learned a lot about how to manufacture them effectively. And now we can kind of pivot and go back towards our original research interest. And of course, BioNTech's not the only company that was going through that journey.
So far we've been talking about this technology and how wonderful it is and how it saved lives. But there's a dark side, which is kind of the combination of people more broadly becoming anti-vaccination and partly because of the rise of the Trump administration gutting the National Institutions of Health, this research is maybe not quite at risk, but like potentially moving a lot more slowly and helping less people than it could otherwise. And I was wondering if you could talk more about what you've seen in that regard, what researchers have told you, like what are we facing in terms of like actually having this technology be deployable on like larger scale?
So we are in a really hopeful moment in terms of the science here. A lot of the technological advances that have made mRNA vaccines possible and practical as a form of cancer treatment in this moment are things that just weren't around 5 or even 10 years ago. It's now really, really cheap to do a genetic sequence of a tumor. You have all these tools, these algorithms that can predict how different kinds of proteins will appear in the body, and that's important to sort of figure out which of the different mutations in a tumor we might go after with a vaccine. So all of these exciting developments have kind of converged on this field at a moment when all of a sudden cancer research is kind of taking it in the chin. We saw what I think a Senate report estimated to be a 30% reduction in federal funding for cancer research just in the first few months of the second Trump administration earlier this year. We have since seen cuts to major federal grant programs that supported mRNA vaccines for other diseases. So those haven't yet targeted the ongoing mRNA vaccine trials for cancer, but certainly that is an anxiety that a number of researchers expressed to me. And I think you also have, for Americans, this new reason to question the sort of primacy of the American research establishment on a global level. And institutions that are used to getting the absolute best and brightest scientists who are up and coming from around the world flocking to New York and flocking to LA and Boston, wherever it may be, to, go in and implement their bright new ideas. Those people are now starting to kind of wonder. I had a couple conversations with folks just about how different it feels to recruit young postdocs who are figuring out, well, where does it make sense for me to start my researching life? Is the decades-long support for the kind of science I want to do going to be there if I decide to make that choice in the US? And so, as hopeful a moment as it is, I think there's a very long shadow over the field at this moment because these things take generations to develop in some ways. Even the tissue samples in the study that developed the vaccine for Barbara Brigham, the people who provided the earliest tissue samples that went into that study had, died years earlier. And so there's this really long-term dimension to cancer research that is very, very important. And I think the longer the sort of interruption or pause or even just sort of uncertainty persists, the more people worry, are we going to be able to rebuild or sustain the institutions that have made this research possible?
It also feels like a little bit like, I don't want to say that the people, who died early on were choosing to sacrifice themselves, but it is a sort of sacrifice to say, I know that I'm not going to survive. I'm going to allow myself to be kind of poked and prodded for medical science so that, the future generations can survive. And it seems like we're really at risk of kind of losing that sacrifice.
100%. You need to give people a reason to feel that what they are doing is going to matter to somebody. I think it's great that people are willing to participate in studies, but as you say, it's not that it's going to negatively impact their treatment, but the sales pitch is basically, hey, we don't know if this thing will work. You're at the most difficult moment of your life. You may have limited time left with your family, whatever you want to accomplish in your career. You have all kinds of new metaphysical thoughts about mortality and these things, and we're asking you to spend an extra day at the hospital, to meet with one more specialist, to allow our graduate students to be in the room, to go through a kind of selection process where we determine, are you in fact eligible for this kind of new line of treatment? And so even if it does hold out a little bit of hope for improved health, it's not always, I've got to think, an easy trade-off. And we should really cherish people's willingness to participate in what is really a sort of an act of solidarity, not only just across place, but across time, and try to support that as best we can.
That's really beautiful. And I think that's a really good place to end this. So thank you so much for your time.
Thank you.
You can read Rowan's upcoming piece on scientificamerican.com on November 18th, or check it out in the December issue of the magazine. And don't forget to tune in on Monday when we go on a time-traveling journey with Scientific American's editor-in-chief, David Ewald. Science Quickly is produced by me, Kendra Pierre-Louis, along with Fonda, Mwangi, and Jeff DelViscio. This episode was edited by Alex Sugiura. Shayna, Posses, and Aaron Shattuck fact-check our show. Our theme music was composed by Dominic Smith. Subscribe to Scientific American for more up-to-date and in-depth science news. For Scientific American, this is Kendra Pierre-Louis. Have a great weekend.